am Renu Sharma, Assistant Professor, EC Department. Today I am going to start with the next lecture, that is related to multiple access for the subject, that is wireless and mobile communication. So, these are the topics that we are going to cover today, that is first one is Rake Receiver, then multiple access for radio packet systems, which consist of pure Aloha, slotted Aloha, CSMA and their version. Now, what is CSMA? CSMA is carrier sense multiple access. So, all this is related to multiple access, which means when more than one transmitters are there which will going to use a common channel. So, they have to follow a particular pattern, so that the traffic is not there or collision is not there, which means that when the data which is transmitted among the different users, then they will not collide. After collision, if the collision is taken place, then there will be loss of information. So, to avoid that we have to follow a certain pattern in case of this multiple access technique. Now, first we will begin with what is Rake Receiver. A Rake Receiver is a radio receiver which is designed for the purpose to counter the effects of multipath fading. Now, what is multipath fading? Since there are multiple hop or multiple objects are there in between the transmitter and receiver, because there is in practical application there is no direct line of sight exist between the transmitter and receiver. Whenever we are going to transmit any information, then it has to follow different paths, then there will be a building will be there in between the transmitter and receiver, there may be a tree or some other obstacles are there which will going to degrade the quality of the signal, and these obstacles are going to change the characteristics of the signal. Maybe the signal will be delayed and it undergoes fading. Fading means the strength of the signal with reduced with the increasing number of hops. So, that is the case where rake receivers are used to reduce that particular effect. Now, due to reflections from multiple obstacles in the environment, the radio channel can consist of multiple copies of the transmitted signal having different amplitude, phase and delay. So, there are 4 different factors that will be there, like first one is reflection, then refraction, scattering and diffraction are there. So, these are the 4 names or the 4 phenomena that will occur when there is multipath exist between the transmitter and receiver. So, as with the case of reflection, when it will going to follow different paths, then definitely the different version of the transmitted signal will exist, which have their own amplitude, their own phase or delay. So, a rake receiver can resolve this issue and combine them. For this purpose, several sub receivers are used, which are known as fingers. Now, you can see over here that there is one signal, that is M1, this is M2, this is M3. So, these 3 signals are there. There is only one signal which is transmitted, but due to the multipath propagation, due to the fading, there are different version of the transmitted signal will occur, that is M1, M2, M3. This is the receiver antenna, then this is the received signal, that is RXT. So, all the signals will be passed through correlator 1 to correlator M. So, there are M number of correlators are there, depending on the number of components of the transmitted signal that will be received, that is applied to different correlators. Then this is applied to a combiner. Combiner is nothing, it is a sum which will going to take the sum, calculate the sum of the all the signals which is been taken as an output for different correlators. Now, this is applied to an integrator which will going to integrate the signal. Then there is an decision making device is there that has greater than or less than sign, which means it will going to check that whatever signal is integrated, whatever will be the output of this integrator, it will be checked that whether it will be greater than a particular threshold value or it is less than a particular threshold value. Then we can say this that yes, this empty signal is received properly. So, this is the introduction of rake receiver. So, when the transmitter transmits the signal, then it travels through environment which consists of various obstacles and the transmitted signal is reflected by them. then it is received by rake receivers from multiple paths. So, you can say, let us say this is the transmitter which will going to produce a signal which is denoted by MT. Now, it has to travel over the channel, and there are, let us say there are multiple hops are there, all are having different distance. So, all have to be received at this particular point. So, this signal is known as M1, this signal is known as M2, this signal is known as M3, this is M4. So, all are having different phase, all are delayed version of the original signal MT. These all have to be added at the receiver side using the rake receiver. So, the delay in each received signal are compensated and are fed to the combiner, integrator and comparator, which combines them suitably with different appropriate time delays. So, what is the advantage of using this particular rake receiver? So, first is it improved the efficiency and performance, it improved the signal to noise ratio. So, when we are dealing with this analog type of communication, this signal to noise ratio is a very important parameter that we have to calculate. It will going to calculate the received signal power divided by the noise power. Now, noise will going to affect at the channel mostly, that is additive wide Gaussian noise, and also there are different phenomena are there like atmospheric propagation is there. So, these are also going to affect the quality of the signal, that will act as a noise only. So, that is also the case where we can reduce that particular noise and increase the signal to noise ratio with the use of this rake receiver. Now, disadvantage is that it has increased cost of the whole system and makes the system more complex, because since we require more number of correlators, like we have received 4 let us say 10 version of the transmitted signal, that is MT. So, 10 correlators are required, that will definitely going to increase the complexity of the system that we have designed for the purpose of demodulating the particular signal. So, that is the biggest disadvantage of using this type of receiver. Now, next is packet radio media access protocol. So, multiple access control channels are there. Now, you can see over here that each MS or the mobile station is attached to a transmitter or receiver, like there are n number of mobile stations are there which are connected to a shared multiple access medium. Now, this shared multiple access medium has a transmitter and receiver which will going to transmit and receive a particular type of signal. It will communicate with its BS or the base station via a control channel. So, there are two types of channels are there. First one is voice channel, another is the control channel. Voice channel is used to transmit only the voice signal between the transmitter and receiver, or any other intermediate node is there, but the control channel is basically used to transmit the control signals, like to control or to send any useful information. So, communicates with its BS base station via control channel. Now, control channels shared by other mobile stations are there, which should be equal to multiple access control channel. Transmission from any MS is received by all the MS within its radio range. So, this is the particular diagram which is showing that how these mobile stations are connected to a single shared multiple access medium. Now, this multiple access issue, what will be the issue if different mobile stations are connected to a single shared channel? If more than one MS transmits at a time on a CC to BS, that is control channel to base station, a collision occurs on this CC. So, how we are going to determine which MS can transmit to BS? So, multiple access protocol or the MAC sublayer solve this particular type of issue. Like in case of multiple access, what is the main issue? Like if all the, let us say there are 20 different devices are connected to a single communication channel and all will going to transmit at the same point of time, then definitely the collision will take place, because the channel is not ideal and it will going to transmit the control signals. So, definitely there will be a collision. So, this will be removed by using this MAC sublayer protocol. So, this is medium sharing techniques are there, like this one is static channelization and dynamic medium access control. Now, this is again divided into scheduled and random access protocol. So, there are different types of protocols or the set of rules that has to be followed by when we are considering this multiple access technique to reduce the collision effect. Now, this is packet radio media access protocols. So, a medium access control protocol is needed for a multiple access network. Such protocols are designed to address the problem of how to share a common broadcast channel. So, this is just a technique that how a particular common channel has to be used, so that it will be used for multiple access network. The techniques that have been used for the packet radio networks can be termed as random access or contention techniques. Now, what is random access? Random access is basically when there is no let us say 4 users are connected to a common channel. So, there is no particular pattern that first user will going to transmit the data, then second user will going to transmit the data. So, in case of random access, whichever user wants to transmit the data, whether the channel is free or not, whether it is busy, it will not going to check the channel that whether it is free or busy, it will randomly going to access the particular channel. So, that will going to cause problem or collision will take place in that particular situation. So, they are random access in the sense that there is no predictable or scheduled time for any station to transmit. Stations generate packets for the transmission at random times. They are contention in the sense that no central control is exercised to determine whose turn it is. So, all stations contend to for time on a particular network. So, this is the characteristics of the packet radio media access protocol. So, you can see in this flow chart that this is the multiple access protocol. So, there are two types of methods are there, like first one is the contention based, which means it is based on the collision. Contention means traffic, how much traffic is there. So, how we are going to access a particular channel. So, this is the random access. In case of random access, it is Aloha and CSMA, which we are going to discuss today. Then in collision resolution, there is tree method, window method. In case of collision free, there is FDMA, TDMA, CDMA, token bus and DQ-DP. This we have already covered. So, today we are going to discuss this Aloha and carrier sense multiple access, that is CSMA. So, there are 3 medium access protocols appropriate for packet radio networks, like first one is Aloha, second is slotted Aloha and other is the CSMA. There are 2 types of Aloha, there is slotted Aloha and pure Aloha. 2 types of Alohas are there and CSMA. So, what is Aloha? Aloha or pure Aloha is developed in the year 1970 for a packet radio network by University of Hawaii. Its principle is sender S may transmit a packet at any time, hopping, no collision will occur. Then S finds out whether the transmission was successful or experienced a collision by listening for an acknowledgement broadcast for the from the destination station. So, what happened? Like this is the transmitter, this is the receiver. Now, this will going to transmit, this is, you can say this is the sender, this is the receiver. A packet will be transmitted, let us say this particular packet A, this will be transmitted without seeing that whether the particular channel is free or not. Then in return it will going to receive an acknowledgement. Now, it can be a positive acknowledgement, it can be a negative acknowledgement. Now, NAK is negative acknowledgement, ACK is positive acknowledgement. So, in return it will going to listen the acknowledgement. If it is positive acknowledgement, then it says that yes, the particular packet A that we have transmitted is received without any collision, there is no loss of information, and if NAK is received in return from the receiver, then it says that yes, the collision has taken place or any other problem is there and loss of information will be there. So, example is packet 2 from the MS 2 and packet 3 from MS 3 collide. So, MS 3 retransmits the packet 3 pretty soon, and after the collision has taken place and when the negative acknowledgement has been received, then retransmission of the packet will be there. Let us say we have received an AK when we have transmitted packet A, then in return if NAK is received, then packet A has to be transmitted again. So, that is the very basic concept of pure Aloha. So, this is the MS1 packet, this is MS2 packet, you can see this is MS3 packet, and this is the receiver. So, you can see over here that at time t minus t we have transmitted, we have this particular packet, this is at time t, this is t plus t. Now, you can see over here that before it has been received, it will be collision has taken place. So, retransmission will be there for packet third and packet second, because there will be loss of information or overlapping of the information is there. Now, what is the throughput of Aloha? So, there are two different formulas to calculate the throughput. One is for pure Aloha, another is for the slotted Aloha. Now, in this case the T is the packet length, that is the duration which is required to transmit a particular packet from the transmitter to the receiver. Probability P n, that n packets arrive in time 2 t. So, if 2 packets of length t arrive in time greater than 2 t, then they did not collide. So, this is the formula that we have to use to calculate this particular probability, that is probability of n is equals to 2 g to the power n e to the power minus 2 g divided by n factorial. So, where g is the normalized offered traffic load for the particular channel. Now, if we want to calculate at n is equals to 0, so this formula reduces to e to the power minus 2 g. So, this particular formula, that is S is equals to g into e to the power minus 2 g is the throughput formula for pure Aloha. So, maximum throughput for the Aloha when g is half is given by this particular formula, that is 0.184. So, that is the maximum value for the pure Aloha when g is equals to half. Now, next we move to slotted Aloha. Now, in this slotted Aloha, the time axis means the time duration which is required to transmit the particular packet, it will be divided into different slots. Now, you can see in this particular diagram I am going to discuss, like this is transmitter 1, transmitter 2, transmitter 3. So, 3 stations are connected to a channel, then the time axis, this is time axis. This particular axis has to be divided into equally spaced slots, these are known as slots. So, let us say this particular packet will be transmitted, then this particular packet will be transmitted, and this is how, this is 1.1, this is 2.1, this is 3.1, means first packet of the third user, first packet of the second user, first packet of the first user. So, this is how the packets will be sent in different slots, and there is also possibility of collision in this particular section is also there. Let us say it has 2 packets and it has transmitted in this one. So, you can see that this particular packet will going to collide with this single packet of transmitter 2. So, this is collision will also take place, but it has an advantage over pure Aloha, that particular time axis is divided into slots and it will going to reduce the collision with at a greater rate. So, time is slotted, slot length, packet length, duration is t. Packet transmission can start only at the beginning of a slot. So, this reduces the collision duration. Then pure Aloha is there. So, if the packet 1 is almost finished when it collides with just starting packet 2, collision can last for nearby t plus t, that is 2 t. So, slotted Aloha is there, like 2 packets can collide only when both are just starting, which is equals to collision can last at most t duration. So, the example of this particular slotted Aloha is there, like packet 2 from MS2 and packet 3 from MS3 will going to collide. So, MS2 retransmits the packet 2 pretty soon and MS3 will going to retransmit the packet 3 much later that is it will going to wait for a random time instant. Like you can see in this particular diagram, like this is the MS1 packet, this is MS2 and MS3 packet. So, this is the time duration at which this transmission has been started, and in this case this transmission has been started and the collision has taken place. So, retransmission of second packet and third packet will be performed when we are going to transmit this particular data. Now, this is the graph which is showing the throughput. One thing I want to tell you that in this case the throughput for slotted Aloha will be this one, that is throughput for slotted Aloha, which is different in the manner that in case of pure Aloha there will be 2 included in the at this place, but in this case no e to the power minus g will be there in case of this slotted Aloha. So, there is a slight difference in both the formulas. Now, this is the graph which is been drawn between this throughput for different values of S versus traffic load, that is G, which means like S is equals to G into e to the power minus 2 G and S is equals to G into e to the power minus G. So, this is for pure Aloha and this one is for slotted Aloha. So, by putting different values of G we have calculated S. So, a graph will be drawn over here. Now, you can see over here that maximum throughput will be there in case of slotted Aloha, because the probability of getting the packets being collide is less as compared to the pure Aloha. Now, next part is CSMA, that is the carrier sense multiple access. Now, CSMA comes with 2 versions, like first one is CSMA CA, another is CSMA CD, which means this is carrier sense multiple access collision avoidance, carrier sense multiple access collision detection, that is CSMA CA and CSMA CD. So, CSMA protocol give better throughput than both the Aloha protocols by avoiding the collision. Then basic improvement in all the CSMA protocols over Aloha protocols are there, like it will going to listen to the channel before transmitting a particular packet, it will don't transmit if the channel is busy. So, there are different set of rules it will going to follow, so that the collision will be avoided. It will going to avoid some collision, but not all the collisions, like this is MS1 senses the send packet, MS2 it will going to sense packet, then MS3 senses the send packet by MS3. So, there is a collision has been taken place and it will going to retransmit the particular data. Means carrier sense multiple access means the particular channel will be sensed that whether it is free or busy. If it is busy, then the transmitter will not going to transmit the data, and if it is free, then only the data will be transmitted. So, these are the different types of CSMA protocols are there, like first one is the non persistent and other is the persistent CSMA. In case of this non persistent, there is unslotted non persistent CSMA, this is slotted non persistent CSMA. In case of persistent one, there is unslotted, again there is slotted, and here there is one persistent CSMA and this is P persistent CSMA. So, this is the case for different CSMA protocols. So, first one is the non persistent CSMA. So, the steps are, if the medium is ideal, then it will going to transmit immediately. If the medium is busy, then it will wait for a random amount of time and then it will going to transmit the data. Whereas, in this case first one persistent CSMA, if the medium is ideal, then it will going to transmit the data immediately, and if it is busy, then it will going to continuously check the particular channel that whether it is busy or it is free, it is busy or it is ideal, then it will wait for some random amount of time, then it will again sense the data and then it will transmit that particular packet. Last one is the P persistent CSMA protocol. In this case, if the medium is ideal, it will transmit with probability P or delay till the next slot with probability 1 minus P is there. Now, if the transmission was delayed by 1 time slot, then it will again go to step 1. So, there is P persistent means it will transmit the particular packet with a probability P. So, a probability is considered in this particular situation. So, if the medium is busy, it will continue to listen until the medium becomes ideal, then go to step 1. So, P persistent is a good trade off between non persistent and 1 persistent. So, there are 3 types of persistent techniques that we have seen. So, P persistent, which means when we have transmitted the data with probability P, it is much better as compared to non persistent and 1 persistent. These are the references that you can consider for this particular topic. Thank you.